able to deploy that application. And as he said, there are various ways to deploy the application. So this hands-on lab, which I'm going to put the link on the chat room now, just to make it easier for you, you guys will be able to step through and deploy one Kubernetes cluster and the Moonshop application on top of that. You will also be able to look into the Grafana and the horizontal scaling of the pods. And but because this is the first session for the whole afternoon, and this really relies on you having access to your free trial account, I dedicated the first 5 minutes of this session just for you to go and activate your accounts, be able to sign up, and really have access to an OCI console where you can start deploying the resources. So while I rely on you guys doing that, this is the URL that I'm going to also put that in the chat. Let me just give you a bit of introduction about what it is and how we're going to work, right? So the Moonshop app, you've probably seen this before if you're here in the morning. It's a microservice application, and it's a polyglot application. Essentially what it is, every microservice is completely independent, and it stores data required for it to work in different ways, right? As you can see, you have session DBs, you have autonomous database, and it also has a part where you subscribe and you use Oracle events and email notification to subscribe for the newsletter of the Moonshop. Moonshop is deployed on top of the Oracle Kubernetes engine in OCI, which is the Oracle flavor of the management of the Kubernetes cluster. So all the API server, the scheduler, and the etcd database, all that is managed by Oracle here on the blue right-hand side on the slide. And customers really only have to worry about deploying the workloads and actually use the engine. So you don't need to worry about managing etcd or a scheduler or anything like that. You really just push your containers and your deployments against the OKE. And you also can leverage, of course, the OCI register to host your images. So that's used for Docker images, and it also for functions, right? When we talk about in the second half of this lab. From a cost perspective, the OCI registry and the container engine are free. You really only pay for the resources you're using. So if you're deploying a load balancer, if you're deploying block storage to persist your data, if you're deploying buckets in object storage, that's all you pay for. You don't pay for the VMs or for the infrastructure that is required to actually run the cluster. All right. So that said, we should have now with you guys the access to the lab on that URL that I sent a couple of seconds ago, and you should be seeing something like this, right? This lab is pretty much divided in two parts. The first part of the lab is when you're going to set up the environment and deploy Moonshop, and the second part of the lab, lab 4. So labs 1, 2, 3 are about Moonshop, and lab 4 is serverless applications and Oracle functions. So why don't you guys just go and get started, and I'll be here for questions help you troubleshoot. And so I'll be here for the next 25 minutes of the session. And then in the second half, we're going to talk about Oracle functions. All right. So any questions, I'll be attending on the chat or live here if you want to ask a question. Just raise your hand. Right. So as I'm going through the lab myself, I'm creating an, as you can see here during the provisioning of the Kubernetes cluster, one of the things that we have is the ability to create all the infrastructure required for us to deploy the application. So if we follow the hands-on lab here, we can see that there's an option to quick create, and that's going to create all the VCNs and internet gateways and all the other components for me to just hit the ground running and have a functioning Kubernetes cluster at the end of the day. As you can see here, the cluster is being provisioned, and as part of the cluster, we also have a node pool that is being provisioned. So if I go back to my compute and instances, I will see that once my node pool starts to get provisioned, I will have new compute instances being provisioned here, right? It just takes a few minutes for it to come back online, but as soon as I start seeing nodes in the node pool, I'll start seeing VMs, and that's only what I'm charged for. Once that is done, the next step will be having actual access to the cluster. Now, one good thing about OCI that was not mentioned in the morning session is it's this guy right here on the top. It's called Cloud Shell. So Cloud Shell is, as the name suggests, is a shell that is embedded into the cloud console where you can, and you already have pre-configured the cloud CLI, the OCI CLI, the SDKs, and the functions, and a series of other resources where you can interact and start working with OCI straight away from the console. So that saves you time to setting up toolings and etc. And this is actually what we're going to use to interact with our Kubernetes cluster today, right? So we can leave the Cloud Shell running here underneath. And the good thing about Cloud Shell is you have 5 gig of storage, so you can transfer files up and down. You can upload files into your session. You can download. It has, if I'm not wrong, a 24-hour lifespan. So if you close it here, come back in a couple of hours, come back in 10, 12 hours on the next morning, you probably have all the files that you've created still there for you. They're cleaned up every 24 hours, so it's an ephemeral setup. But it's good for you to have a place to start with, and with all the toolings pre-configured, which is really interesting. And with the chances of you having the opportunity to upload, download, and download files, and having all those resources for you to use. So, for example, if I do OCI compute instance list, sorry, my compartment ID, the one I just created, I need to grab it here. Probably in the second page. There you go, that's me. Okay, so my cluster is up. So I ran OCI, compute, instance list, compartment ID. So I got a JSON back with all the compute instances that have been provisioned in OCI for me so far under my compartment. So now that I have a working cluster with a node pool, right? As you can see, I have 3 nodes in the node pool. They're being created now. So if I go back to my compute instances, I can see them being provisioned. 2 are already running. 1 is being provisioned. After that, what we're going to have is Kubernetes actually installing the kubelet on those boxes. As you can see here, the status is now installing software. So now the kubelet is being used, and those are my worker nodes. So a good thing about this, I can have multiple node pools being managed by the same Kubernetes cluster. So for example, I have a certain workload that requires a high level of I/O. I could have a node pool with dense I/O VMs or with bare metal VMs, and one for just regular flex VMs. So I can have all sorts of different things being managed by the same cluster. So different environments in different node pools if I want to. I can have various clusters and manage them all from the same kubectl, kubectl utility, just by setting different context and sending my instructions across. So by now, once this is done, I go to my cluster and go here, access cluster via Cloud Shell. How does it work? I copy this instruction, paste it in here, and now I can interact with the cluster. So still don't have anything because my nodes are still being created. While this is running, we can look into what we're going to do. So the MooShop app, it's accessible via this URL. So here you can have all the source code for MooShop. In the interest of time, I'm gonna use another cluster that I have here that is already created. So I'm gonna access the cluster, copy, put it in here. So now I have kubectl get nodes. So I have 3 nodes here ready to be deployed, into. So with the lab now, we obtain the code. So just do a git clone. Now I have my MooShop source code here, and you can see the various deployments here. So we have the basic deployment, which is the lightweight, always free deployment of MooShop. You have the complete deployment, and within the complete deployment, you have a Docker Compose version, a Helm chart version, and a Terraform version. So with the Terraform runs and sets up everything for you. What we're going to use here in this lab is we're going to use the Helm chart version of it. So if I continue on, I'm into the MooShop directory. As I said, here's the directory structure. Then we can see my context. I have a namespace called MooShop. I'm going to change my context to that namespace. And then I'm going to create another namespace called MooShop Utilities. So if I go here, I have a new MooShop Utilities. And then what I'm going to do is I'm going to run Helm dependencies. So Helm is a way that you have to package and control your deployments in Kubernetes, right? So you create what it's called Helm charts, or specify everything that your deployment needs, all the containers and pods that will work together in order to have one deployment. And the Helm chart takes care of all the orchestration between those different deployments that you have in order for you to have a desired outcome when it comes one big package for you to deploy, to do version control or upgrades. So when I run a Helm dependency update, all it does, I'm sorry, I'm in the wrong directory. I was showing you the source code, so here it is. So it checks for updates on all those charts that I'm going to, for all the charts related with the chart that I'm deploying. So in this case, I have Prometheus to collect metrics from the hosts and from the actual cluster itself. Then I have Kubernetes. I have Nginx, which if you go back to the picture, it's the ingress controller, and Grafana. That's going to be responsible for where I create my dashboards and see my metrics. So once that is done, it also creates for me behind the scenes a load balancer for my ingress controller. The load balancer has an external IP of 168.138.22.14. So if I go here, networking, load balancer, here I have my load balancer created for me by OK, right? I then check the deployments that I have with my Helm chart, that would deploy with my Helm chart. So those are all my deployments. Grafana, Nginx, a metric server, 3 different deployments for Prometheus, Grafana, right? The next step is really deploy the actual MooShop, right? In this case, in the interest of time also, we're using a setting called mock service. So what it does, it stubs out all the peripheral services instead of creating them all, because creating them all in this time frame that we have, it wouldn't be possible. So when we do this, it actually starts spinning up all the pods for MooShop. So you have the API server, the cards, orders, payments, all the different pods that are part of the deployment, right? All wrapped up and packaged up with this Helm chart here. Once that is done with that IP, 168.138.22.14, I should have access to the actual store. And here I can navigate, see my catalog of products, purchase something, and this is all being backed by those different services. So if I go about.html, this is that interactive page that tells you about what the services is doing. Right, next thing is Grafana. So if I go same URL / Grafana at the end, same IP address / Grafana at the end, I'll get to the Grafana login page. To obtain the Grafana password that is generated as an OKE secret, you run the kubectl get secret and you decode it with base 64, and this is a temporary password that's generated. You log into Grafana, you see something like this, and you have access to the pre-deployed dashboards, right? Here's one where you have CPU and memory usage for some of the pods, so I can filter out the pods that are running in Moonshop, and I can say, I don't know, Moonshop API, and then I start seeing how much memory and CPU they use, how much network traffic it's actually generating. The next thing in this lab is really for us to navigate and explore the app as we were doing and see what it actually does behind the scenes. So we can see the pods. So for example, if we run this, we can see what the pods are doing. So for example, right, so now I'm using Moonshop pod, Moonshop user, right? And then I'm just gonna do this F so I can see the log going on as I navigate through the various products and services under my app. So I see the logs going on. All my GET and POST requests, those are all the logs on in my pod, right? I can log into the pod if I want to and run commands against it. So this is the content of my pod in this case. And one interesting thing is I can generate a template out of this to actually be able to see, and I can, as I said, with the Cloud Shell, I can actually download. And if I run this command, the Helm template, I'm templatizing my deployment and generating a whole bunch of YAML files that describe my services, right? What is it doing? What images are being used, annotation, labels, and all the details for the different pods or the different components of my deployment. The next thing is monitoring the OKE. Mickey said in the morning that you can access cluster-related metrics and node-related metrics from the actual OCI metric services. So if you go here, metrics, you will start seeing metrics here. from the node pools as well. So you can have metrics for the nodes, if the nodes are up and down. From the actual compute that is backing the hosts, you can also see like CPU, memory utilization, disk I/O, network, load average of the boxes, and etc. All from the metric services. In here, what we're going to do is access the Grafana. As I was saying, this is a command you use to get your temporary password. You will see a welcome screen, access Grafana, and here's some of the dashboards that you can visualize, right? And during this lab, one of the last portions of what we have is showing some horizontal scaling. So this deployment has some horizontal pod scaling configured. As you can see here, I have all my pods and I have one replica for each, and I can get up to 10 pods depending on my thresholds here. So what this lab shows here, I'm going to see all the replica sets that I have. All right. And sorry. Here I'm going to generate some fake load, simulating as if I had users actually navigating, purchasing items out of my e-commerce shop. So this creates a whole series of pods. They are going to start sending load against my pods, and you should see my replica sets now. My targets starting to increase from 1% to, you will see it coming up. And then I can also see here, I can leave it on the API server, I believe. Sort of last 6 hours, let's get the last 5 minutes. And I should have data coming up here real soon. There you go. So once this starts to increase, you see 68%. I can see that it's now going up, the memory usage for that pod. I could also check Kubernetes cluster metrics. I could see the average load of the boxes of my three different nodes over time. As my pod's starting to pick up, I have some memory intense pods coming up here. My loads will start spiking. So if I change here, last 5 minutes, I see that my idle time was 100%, so there was nothing happening, and now I'm starting to decrease, which means I'm having activity. As you can see, one of my nodes just went sky high. The other two are still receiving other loads depending on where those pods are placed. And it will eventually come down, right? You can see this is just a simple response. We see the pods coming up. We can see with Grafana the memory and consumption of my resources. This is all out of the box. Those dashboards were written as part of the MooShop app. And I can at any time delete the load. So I should see that reflecting on my horizontal scaling. My targets will start to come down again, and my graph will start going back to pretty much idle. There's nothing else running here, really. With that said, I think we've finished this section of the lab. just in the interest of time, because we still have to cover the functions part, and I will hand it over to my friend Sukumar to take over from here. All right. Any questions, guys? I can't see any questions on the Q&A. I'll be here throughout the session, so if you have any other questions, you can raise your hand or write it in the Q&A. Okay. Thank you very much for your time.
Yeah, thanks, Simon. This is Sukumar here. I hope I'm audible.
Yeah.
Hello. Okay, awesome. So I think we are already at 1:55. So I think we have 20 minutes before starting the next session. So I'll try and make it as fast as possible. I'll run through the lab and would request respective team members to kindly go through each and every one of the steps and let us know in case you need any help. So let me quickly start sharing my screen. All right, is my screen visible?
Yes.
Okay, awesome. Before I go through the lab, I would just like to take a quick 1 minute to explain what we're trying to do out here. So this lab is about seeing the utility of Oracle Functions, which is the serverless platform that Oracle has built, just like AWS Lambda, but it is completely built on the open source FN project. So the lab is about using Oracle Functions to deploy a particular file onto OCI object storage. Once that file is deployed onto OCI object storage, it triggers an event, and that particular file is uploaded onto OCI autonomous database. And in case people are new to the concept of autonomous database, it is Oracle database completely managed by Oracle on Oracle Cloud. When I say completely managed, it means that the database need not be managed by even a DBA. All the normal day-to-day DBA activities like patching, tuning of the database, taking backups, everything is automated onto autonomous database. So in this particular lab, once a file is uploaded onto OCI object storage, that file will be automatically uploaded into the autonomous database, and you can view the file out there. This is what is going to get automated by the functions. So that's briefly what the lab is about. Going back to the same page that Simon was showing, we will start once I think Simon showed till lab 3. We will start lab 4 now. But before starting lab 4, it is important to know the prerequisites, right? So the first prerequisite is you log into your OCI tenancy. In case you have been following Simon's lab, you would be already into OCI tenancy. In the first lab itself, you need to create a compartment which is called AppDev. So that is the second part of this particular segment. You create a compartment called AppDev. You can obviously give it any name that you want. But going with the lab, will have you can use the same name, okay? And then once you create the compartment, you create the VCN and the subnets. Simon also showed how you can quickly create the VCN and the subnet. So what you can do is you can use the same compartment AppDev that you would have created for the first lab, and within that compartment itself, you can create this new VCN and name it, say FN VCN as it is given out here. And you can use the same quick start menu so that the VCN will be automatically created with all these subnets. And for the purpose of this lab, I think a private subnet and a public subnet both are created. So it will get automatically created, all the internet gateways, all the route tables, everything will be automatically created. So you can use that. And the next important part, and this is the most critical part, is to write the various policies that you need to use functions on OCI. Okay, so that is task 4, as you can see from the screen out here. You need to create a policy for Oracle Functions Service. Okay, So you can now this policy is to be created in the root compartment. Now, if I can show you my OCI console. Yeah. So this is the section that you need to get into, identity and security. If you click on identity and security, you get this section called policies, right? And here is where you need to write your policy. So here's the compartment. You need to choose a particular compartment in which you're writing the policy. You need to create here, click here, and you need to write the various policies that are given in the particular lab. So going back to the lab, you have to, the first policy, the functions policy that you create has to be done in the root compartment. So the root compartment is essentially the parent compartment. And inside the root compartment, you would have created the app-dev compartment in the previous section. So you can name it as the FAAS policy, okay? And then you can write the various statements that are given in this particular lab, okay? All of these statements, you have to include all of these statements as part of the administrators group in AppDev. In my case, I already have it created. So if I change from here, if I go to my root policy, and this is my own tenancy that I'm using, I have this FAS policy as shown in the lab, and as you can see, all the policies that are required for that particular compartment are all included as part of the policy statement under the root compartment. This is a critical part. All right. Moving on, the next step is to create a dynamic group. Okay. And this dynamic group, again, if you go to identity, you will see this section called dynamic groups out here. And this is where you write your dynamic group. You have to basically write the group in the particular compartment in which you want to write the group. So as you can see from here, you have to again go back to your AppDev compartment and write the particular dynamic group for a statement. And this is the dynamic group statement. So it typically allows your functions to access resources in the compartment AppDev that you would have created, right? So you need to write the functions dynamic group statement. As you can see, I have already done that. And this is the OCID of the compartment, that is the AppDev compartment that you would have created. This is the OCID. You need to write the OCID out here, and you need to write the particular statement as given in the lab. All right. So please, my request to every one of you is to follow every step that is given in this lab, step by step. Please do not skip any particular step. That if you miss one particular statement, or if you miss particular syntax as given in the lab, then eventually your lab will not work. So please be mindful of that. All right. So this is the prerequisite part that we need to do before we move on to creating the actual function. Okay. So moving on, the next, but now actually the lab starts, right? So you need to create a bucket. You need to create the policies, and some more policies need to be created, and you need to create the autonomous database. Okay. So if I move on. So first of all, you have to create an object storage bucket for input. So this is the bucket that you would create for uploading the CSV onto Oracle object storage. All right. So where you can get it, if I go back to the menu again, if I go to the storage section, I get buckets out here. Okay. And if I go to my compartment again, right? So here is where you need to create the input bucket and a process bucket. Two different buckets need to be created as given in this particular lab. So there's an input bucket that needs to be created. So this is the bucket wherein your file will go. And then an output bucket needs to be created. An important aspect is you need to select this option called emit object events. Now, for example, when I'm creating the bucket, I give the name here input bucket as given in the previous as given in the lab, and then when you're creating this bucket, you need to select this particular option called emit object events. So only when you select this particular option, then once you upload the file onto OCI object storage, your event will be triggered that the file has been uploaded, and that is when the function will work. So this selecting this particular option, emit object events, is very, very critical. In my case, in the input lab, as you can see, I have already done this. I have already emitted this, but selected this particular option. All right. Now going back, yeah, you create your buckets. Okay. Then you create a bucket for the processed files as well. Although this will not be used that much. And again, the important part is you need to write three different policies for this particular bucket. So these two statements are mentioned. So please use the exact name as given in the particular section out here. Okay. And for your reference, how the screen will look like once you're creating the policy is given here, as you can see. So it will look exactly the same. All right. And then you need to create again a policy. So as I said, right, in functions, a lot of policies and dynamic groups need to be created. So you need to be wary of this particular part. All right. So again, you need to create a policy on OCI object storage. So this policy essentially we will give you the option to manage objects and files inside object storage. The important thing to note out here is the region. All right. So object storage region name. So in case you are using, say, Ashburn region, the syntax is given here, US Ashburn 1. Or if you're using some other region, in case you want to know what is the URL, you can see from here. For example, I'm using India West Mumbai region. So the region name is given here, AP Mumbai-1. So irrespective of whichever region you choose, you can get the name out here. You can use that particular name in this particular statement. That's the important part. Otherwise, the statement is the same. So once you do that, the next step is to create an autonomous database. Very, very simple. You can create an autonomous database in a few clicks. So if I go back to my screen out here, if I go to Oracle database, and if I go to autonomous database, yeah. So my autonomous database has given the lab is already created, but essentially if you have to create this particular database, there are just a few things that you need to add. You need to give the compartment name. So this will be appdev in your case. You need to give a display name, a friendly name. So the steps are given here. What is a display name? You can choose this name or you can choose some other name. But I would request you to choose the exact name so that you don't get confused on the policy statements. So you need to give the name, display name. The database name can be same as your display name. You can choose data warehouse or transaction processing. As far as this lab is concerned, doesn't matter. The lab says the data warehouse, so you can use that. We will use shared infrastructure because you will be creating a lab with the minimum requirement of 1 OCPU. So you really do not need a dedicated because this particular database is based on Exadata. So you really don't want to use a full Exadata machine. I mean, it will not be allowed in your trial account anyway. So you choose the default options. And then you need to give a strong database administrator password. That is very, very important. All right. And then you can choose the default options. And the important thing again is to choose license included. So we have these two options, BYOL and license included. BYOL option you need to choose if you have your own license. In this case, you will obviously not have an Oracle database license. So use license included as part of the option and then create the database. Right. So once you create a database, it just takes a few minutes for the database to be available. All right. So you can create the autonomous database. And once you do that, then after that, once the database is created, then you need to go inside the database and all right. So that the screen will look like this. So there you need to click on this section called Service Console. Okay. The moment to click on Service Console, okay, my session is expired, no problem. The moment I click on Service Console, I get this section called Development. All right. Now in this development section, I have this section called Database Actions. Okay. The moment I click on Database Actions, I get the option of using a SQL developer. So You don't need to access autonomous database. You do not need SQL developer on your laptop. You can use this online SQL developer, which is part of the autonomous database itself. So all the steps are given here, right? You need to under RESTful services, and then there's a particular URL that you get under RESTful services, which you need to copy. Okay, and as part of this lab, you need to open Oracle Cloud Shell. Simon has already told you about Oracle Cloud Shell. It is essentially the same Cloud Shell that you would have used just now. I think I already have it opened. Okay, once. Yeah, I already have it opened out here. Okay, so you need to go to Cloud Shell and you need to write these two particular commands. Okay, so you have to export the ORDS base URL. This base URL you will be getting from the previous step. Okay, and then probably what you need to do is you need to note it down in a notepad. So export the base URL. You can copy the URL, and this is, in my case, this is the URL I have. In your case, obviously you'll have a separate URL, and then export a DB password. In this case, I have used my own password. So these two steps you might want to write down in a particular in a notepad, and then you need to run these two commands for the particular steps. All right. So once you do that, your autonomous database will be ready, and then you are free to move on to the next section, that is the lab 5, wherein you are actually creating the function. Okay. Now again, this part you need to make a note of a few points. Okay. So what you need to do is you need to create a function. You first need to create an application. So going back to my screen. All right. So here you need to go to developer services, and in developer services you get this section called functions. So once you go there, the first thing that you need is you need to create an application as given in the lab. So in my case, I've already created this application called ETL app as given in this particular lab. So this is already created. All right. And then you need to select the VCN, again, the function FN VCN that we have already created on top. You need to select this. Okay, just follow these steps. And then the important part is once you create the application, right? There are certain steps that you need to follow, which is the Cloud Shell setup. So, okay, so let me create just a sample application, not related to this lab, just to show you the steps. Okay, so maybe I can just mention it as a test app, say. Okay, I will choose my public subnet and I say create. Okay, so once I create this particular application, you can see this Cloud Shell setup. Okay, so there are certain steps that are given in as to how you can deploy this application in the Cloud Shell itself. All right. Now, in this particular setup, you need to stop at 7. So, step number 7. So, what is step number 7? Step number 7 is once you deploy your function, there's an authentic the Auth token that you need to create, and then you need to use that particular Auth token to log into OCI registry. So, OCI registry is where you will be deploying all your containers, and then step 7 is when you list the application. Now, after that, there's a sample Hello World application that you can deploy for testing your function. But in this case, we're not going to use the Hello World function in step number 8 onwards, because we'll be creating our own application, right? And to create the own application, the steps are given here. Okay. So what you will do is you will deploy this function from the functions in a code repository. All right. So if I go back to my Cloud Shell, so this is the sample repository that you can clone from GitHub. Okay. So I've already downloaded this particular folder. So you need to copy this URL. Just do a quick git clone, and then this particular folder will be downloaded. Then you need to go to the next step. That is, you need to go to this particular folder, which is a OCI load file into ADW Python. So this is the particular step that we are doing, that wherein we'll be loading the file onto OCI object storage, and that will be deployed in the autonomous database. All right. So you need to say copy, and if you paste here, okay, you can get to this particular directory. If you do an LL, you see the various files, file1.csv, file2.csv, file3.csv, all the functions that are already deployed out here. Okay, and then you need to deploy this particular application. So once you go to this, you need to deploy this particular application. So let me do that. I'll just take a minute. We are already at 2:16. Shashi, you are there?
Yeah.
I think you are doing the next session, right?
Yeah, Sukumar and me and Roshni are there. We'll be doing this next
So
session.
just give me a minute more. I'm just concluding, right? This is the final step.
Sure.
Right. All right. So the function is now deployed. All right. Then the important thing is you need to run these two particular commands. So let me do that. Yeah, this is done. Then the password. All right. Then okay. And now after that, you have to create the event rule. So we create once we created the object onto OCI object storage. So you need to create certain rules. If you remember, we selected the option emit object events, right? Because that option is selected. So now to use that option, you have to create this event rules, where you can create. If you go back to the screen, you can go to observability and management, and you can get the event service out here, wherein you can create the rules as given the particular lab. In my case, I've already done that. All right, load CSV into ADW. That's the event name. You need to create the particular event and the couple of attributes for the compartment and the bucket as shown here. All right, and then once the event rules are created, that's when you are ready to test a function. So let's see if everything is fine and I can access it. All right, so let me go there. Let me upload the file onto OCI object storage. All right, let me see if my object storage has the particular file. I go to storage, I go to buckets. All right, I can go to input bucket. Let's see if my file is uploaded. Yes, my file is uploaded. And this should have triggered the event in the autonomous database, right? So I have to log into the autonomous database, go to the service console and see if this is got created. So let me do that. Okay. So yeah, so this is my DB. So let me give my username, admin, the password. What is the password? This. Okay. I will go to development, database actions. Okay, I guess I need to give the username and password again. Yeah, I go to SQL. Let me see if everything is working fine. So I need to copy this particular statement. Okay, and then run it. And yes, I can see the table the way I have deployed in the CSV file, right? This is the output that you can see, and that is precisely what the lab talks about. This is a final step, which means, yeah, this is the final step, as you can see out here, which means that my function is working properly. I have uploaded the file onto OCR object storage. It has triggered an event, and that event is, what is that event? The event is deploying that particular file onto the autonomous database. And once I run this command, I can see that the file has been successfully uploaded onto autonomous database. So that concludes the lab. I had to make it very quick because of the paucity of time, but you can go through each and every step